Hello everyone, welcome to my lecture. Session hijacking is when a hacker takes control of a user session after the user has successfully authenticated with a server. Session hijacking involves an attack identifying the current session IDs of a client/server communication and taking over the client session. Sequence prediction. TCP is a connection-oriented protocol responsible for resembling streams of packets into their original intended order. Every packet has to be assigned a unique session number that enables the receiving machine to resemble the stream of packets into their original and intended order. This unique number is known as a sequence number. If the packets arrive out of order, as happens regularly over the internet, then the SN is used to stream the packets correctly. As just illustrated, the system initially a TCP session transmits a packet with the sync bit set. This is called a synchronized packet and includes the client's ISN. The ISN is a pseudo randomly generated number with over 4 billion possible combinations, yet it is statistically possible for it to repeat. When the ACK packet is sent, each machine uses the SN from the packet being acknowledged plus an increment. This not only properly confirms receipt of a specific packet but also tells the sender the next expected TCP packet SN. Within the three-way handshake, the increment value is number 1. In normal data communication, the increment value equals the size of the data in bytes. Hacking tools used to perform session hijacking do sequence number prediction. To successfully perform a TCP sequence prediction attack, the hacker must snip the traffic between two systems. Next, the hacker or the hacking tool must successfully guess the SN or locate an ISN to calculate the next sequence number. This process can be more difficult than it sounds because packets travel very fast. When the hacker is unable to snip the connection, it becomes much more difficult to guess the next SN. For this reason, most session hijacking tools include features to permit snipping the packets to determine the SNs. Hackers generate packets using a spoofed IP address of the system that had a session with the target system. The hacking tools issue packets with the SNs that the target system is expecting, but the hacker's packets must arrive before the packets from the trusted system whose connection is being hijacked. This is accomplished by flooding the trusted system with packets or sending an RST packet to the trusted system so that it is unavailable to send packets to the target system. Hacking tools. Juggernaut is a network sniffer that can be used to hijack TCP sessions. It runs on Linux operating system and can be used to watch for all network traffic, or it can be given a keyword such as password to look for. The program shows all active network connections and the attacker can then choose a session to hijack. Hunt is a program that can be used to snip and hijack active session on a network. Hunt performs connection management, addresses resolution protocol, spoofing, resetting of connection, monitoring of connections, media access control, addresses discovery, and snipping of TCP traffic. TTY Watcher is a session hijacking utility that allows the hijacker to return the stolen session to the valid user as though it was never hijacked. TTY Watcher is only for Sun Solaris systems. IP Watcher is a session hijacking tool that lets an attacker monitor connection and take over a session. This program can monitor all connection on a network, allowing the attackers to watch an exact copy of a session in real time. T-Site is a session monitoring and hijacking tool for Windows that can assist when an attempt at a network break-in or compromise occurs. With T-Site, a system administrator can monitor all network connections in real time and observe any suspicious activity that takes place. T-Site can also hijack any TCP session on the network for security reasons. and guard systems license this software only to predetermined IP addresses. Dangers posed by session hijacking. TCP session hijacking is a dangerous attack. Most systems are vulnerable to it because they use TCP/IP as their primary communication protocol. Newer operating systems have attempted to secure themselves from session hijacking by using pseudo-random number generators to calculate the ISN, making the sequence number harder to guess. However, this security measure is ineffective if the attacker is able to snip packets, which gives all the information required to perform this attack. The following are session why it's important for a CEH to be aware of session hijacking. 1. Most computers are vulnerable. 2. Few countermeasures are available to adequately protect against it. 3. Session hijacking attacks are simple to launch. 4. Hijacking is dangerous because of the information that can be gathered during the attack. Denial of service attacks are used to render a system or network unusable and are considered attacks against the availability of the user data. When other hacking attempts fail, a hacker may resort to DOS attacks as a way of attacking the system. Even though the data may not be acquired by a hacker using DOS, the hacker can prevent legitimate users from accessing the data. DOS attacks and especially DDoS attacks are difficult to countermeasures. The best option is to attempt to prevent the attacks by using traffic filtering at the firewall or an IDS. Preventing session hijacking. To defend against session hijacking attacks, a network should employ several defenses. The most effective protection is encryption, such as Internet Protocol security. This also defends against any other attack vectors that depend on sniffing. Attackers may be able to passively monitor your connection, but they won't be able to interpret the encrypted data. Other countermeasures include using encrypted applications such as Secure Shell, SSH, and encrypted telnet, and Secure Sockets Layer (SSL) for HTTPS traffic. You can help prevent session hijacking by reducing the potential methods of gaining access to your network. For example, by eliminating remote access to internal systems. If the network has remote users who need to connect to carry out their duties, then use virtual private network that have been secured with tunneling protocols and encryption. The use of multiple safety nets is always the best countermeasures to any potential threat. Employing any one countermeasures may not be enough, but using them together to secure your enterprise will make the attack success rate minimal for anyone but the most professional and dedicated attacker. The following is a checklist of countermeasures that should be employed to prevent session hijacking. 1. Use encryption. 2. Use a secure protocol. 3. Limit incoming connections. 4. Minimize remote access. 5. Have strong authentication. 6. Educate your employees. 7. Maintain different username and passwords for different accounts. 8. Use Ethernet switches rather than hubs to prevent session hijacking attacks.